is through the Adelaide Sustainable Building Network. This is where I met him, and it's kind of been like a long time coming, but it started off as research, and now it's actually a real thing. So I hope you guys are as captivated as the story as I was.
Thank you, Ken.
You know how to work this, right?
Uh-huh.
Okay.
I reckon I'll figure it out. Ken has actually pounded quite a few tyres up at Earthship Ironbank, so thank you, Ken. I'll be talking more about Earthship Ironbank a little bit later at the end of my talk. That's a little project I'm undertaking at the moment. But the reason I got interested in Earthships is because I kind of a little bit concerned about the way things are going on the planet, and I think we do need to rethink things a bit. And I had a lot of questions about them. There's a few things about Earthships that don't seem quite right. For example, they do seem to use a lot of concrete. And I really wanted to try and weigh up everything and try and compare Earthships to other types of homes. So I've spent the last 4 years doing some research at Adelaide Uni, where I'm doing my PhD to try and actually quantify the environmental impacts of the Earthship compared to other types of homes. And I'll also be sort of giving you a bit of an overview of actually what the Earthship is, how it works, and talking about how they might work in our slightly different climate to where they evolved. They evolved in a very cold climate, also quite hot as well, an extreme climate you could say, 35 in the summer down to about -20 in the winter. So it probably makes sense that we do try to slightly adapt them to our slightly different climate. So just to start off with, give a bit of background on me. I built a straw bale house about 10 years ago. Lance Curl, who's in the audience, was one of the people who helped out with that. We love our straw bale home. It works really well. Usually gives us about 12 degrees buffer in the summer on what's happening outside, and about 15 degrees buffer on what's happening outside in the winter time. That's without any heating or cooling. Although we do have a little wood heater that we use maybe for about 2 months in the winter, which just warms up the whole house really quickly and keeps it warm for at least 24 hours. So we don't go through much wood at all. The reason there's a shed there in the top left corner is because the house actually started as a shed and we transformed it into a house. There's another shot of it there. And one thing I really love about it is the vines out the front, which gives great shade in the summer. And of course, it's all passively solar designed, facing north with the double glazing concentrated on the north side. So on with the presentation. The question is, how many people can we kind of fit on planet Earth comfortably and safely? And I reckon it depends on the technology we use and our behaviour, sort of the way we use that technology. And of course, so this sort of is all directly related to our homes and also stuff, of course, like transport and this kind of thing. But this talks about the architecture side of things. And I want to show you this little equation. Our ecological impacts, I, is directly proportional to how many people we use, and so I'm arguing that we need to be energy efficient and also water efficient. And our behaviour, we have to be willing to change, and that's one of the things that the Earthship, I think, really challenges everyone to do. It actually forces people to change their behaviour, and I'll explain how it does that in a minute. The other thing we've got going on, of course, we've got climate change, and there's a book there that you should all read. It's kind of spooky. It says that there's going to be mass migration of billions of people to escape the tropics and the subtropics because it's just going to get too bloody hot and too humid to live there. So that's going to mean a lot more boat people to Australia and elsewhere. We've also got, I believe, high-level corruption. This is the president of the International Energy Agency, and he's in cahoots with, the oil-producing countries. Basically they're making big bucks. We've burnt about half the fossil fuels we've got on our planet, in our planet. Half of it's still to go, half of it's still to burn. And if we burn all those fossil fuels, we got some pretty diabolical problems with climate change. So it's kind of a big problem that's difficult for, our political leaders don't seem too good at solving that problem, and so that's why I really love sustainable housing, because it sort of gives power to the people in a way they can sort of try and, almost escape some of this stuff, especially with an off-grid home like the Earthship, where you can just go, screw you guys, I'm not buying any energy from you, I'm not buying any water from you, I'm doing it all for myself. And just to kind of conclude this little intro, this is David Holmgren, the co-creator of the permaculture concept. This is his sort of take on the future. On the vertical axis, we've got energy, resource use, population and pollution. They're all combined. They're all sort of intertwined, very difficult to separate. And then on the horizontal axis, we've got time. And basically, as the population is increased, our resource use is increased, pollution's increased, and now it's like, well, what happens next? Do we keep on using more and more energy? And do we have more and more people living on the planet and more pollution? Or do we sort of take a bit of a dip, what he calls techno-stability? And this is where you might have lots and lots of renewable energy. So hopefully you've all heard of Beyond Zero Emissions, BZE, which is a scheme to give 100% renewable energy to Australia. It costs about $10 a week per household for 10 years, and we've got 100% renewable baseload energy. That's techno-stability. Or this is sort of David Holmgren's prediction or vision, I guess, is that we actually, over maybe the next 200 years, our population declines and our energy use declines, and we just go back to how things were a couple of hundred years ago, pretty much. Hopefully we still got some solar panels, because I love solar panels. I mean, we all love a bit of electricity, right? But it's not essential to our survival. Or we have collapse, which sort of comes partway up this little experiment up here where things go horribly wrong, maybe a disastrous economic disaster. We've seen a few GFCs, right? And the shit really hits the fan. Let's not dwell upon that. Earthships make sense in all these scenarios. Doesn't matter what you think is going to happen in the future. It kind of addresses and prepares you for all these situations. So let's talk about Earthship design features, just so you're a full bottle on what they are. Michael Reynolds is the architect from the United States who invented this about 40 years ago. And basically they are off-grid homes that do pretty much everything for themselves. They do cheat a little bit. They do use a little bit of gas for cooking and boosting the solar hot water. But the principles are passive heating and cooling, renewable energy, water harvesting, on-site sewage treatment, natural and recycled materials, and food production. So you can see here, this is the greenhouse on the front of the Earthship, where grey water is actually treated and used to grow food. And so, yeah, the idea is that you're trying to be as self-sufficient as possible, particularly in your energy and water. And what this does is it does protect you from, future mishaps, as I've said there, such as the global financial crisis. I mean, let's face it, energy is probably just going to get more and more expensive. Water will probably get more and more expensive, and food will probably get more and more expensive. So, here is something that helps you kind of decouple from that unsustainable system. So we've got a section view up top and a plan view of the Earthship down the bottom. And batteries are usually stored somewhere in the Earthship, sometimes inside, sometimes up on the roof in a battery box. So this has the interesting phenomenon of really limiting your energy use. If you flatten your batteries, you're out of power and you have to start rethinking the way you're running your life, or buy more batteries. There's an earth berm, or simply the berm at the back, which is about 100 tons of earth piled all around the all around the back of the Earthship. So this is the sun-facing side, so south in the northern hemisphere and north in the southern hemisphere, passive solar. And that has a really important function of helping regulate the temperature inside. Inside that berm are water tanks, and that's a really interesting idea. Keeping your water tanks inside the earth protects the water tanks from, you know, UV exposure. It just kind of hides them out of the way so they're not, an eyesore. Protects them from kids with cricket bats and, you know, stuff like that. So also keeps the water at a nice cool temperature in the summer. And would protect it from freezing as well in really cold climates. And a recent innovation of Michael Reynolds is this thing he calls the thermal wrap, which is a layer of insulation all around the tyre wall. So this is the main, so this is one of the iconic features of the Earthship, is that the main walls are made out of tyres. That's them there. Which are filled with earth, which is rammed in there with a sledgehammer or by mechanical means. And this layer of insulation, Mike found that improved the indoor temperature quite substantially. So that's an important design feature in that really cold climate. Although here I'm sort of experimenting with that a little bit. I'm not doing that because I don't believe that we really need that in our climate where it doesn't get quite so cold. There's the tyre walls. Another really interesting feature, and this is a fairly new feature of the Earthship, are the cool tubes that come through the tyre wall and out through the berm. There's one in each main room. They draw in cool air. They cool the air. I mean, it starts out coming in hot summer air, but as it moves through here, it gets cooler and cooler because it's buried under about 2.5 meters of earth, and the earth at 2.5 meters deep is quite cool. When we were digging, we actually dug a trench for the Earthship at Earthship Ironbank up in the Adelaide Hills, and it was a 40-degree day, the day we dug the trench, and the temperature at the bottom of the trench was 13.5 degrees. So you'd be sweltering outside and you'd hop down in this trench, which you really shouldn't do because it can collapse. And it was 13 and it was beautiful. It was lovely down there. There's a vent at the top of the greenhouse. This is the greenhouse here and here. That lets hot air go. So you actually want this to get a little bit warm in the summer, let the hot air go, and that actually pulls the cool air through without any fans. That's sort of another game that Mike Reynolds is playing, is like, how do you make this thing just run by itself without the need for fans and people pushing buttons? Another thing I like about the way Mike's sort of designed this is he's kind of quite neatly integrated solar panels and solar hot water. It's not a tacked on afterthought. And I've kind of screwed that up a little bit on mine. The north-facing greenhouse, which is sort of tilted over on an angle to optimize solar gain in the winter, in those really cold winters in Taos, New Mexico, in the USA. That's all double glazed. There's more double glazing there, which isolates this main living space from the temperature fluctuates quite radically in that greenhouse. So you sort of want to isolate the main living space, and that's a bit of a design innovation. He didn't always do it that way. That's made a big improvement. Then you've got the grey water treatment in the greenhouse where you can grow your food. So every time you take a bath, you're irrigating your plants there. And then there's also a similar system outside the home, the black water treatment. And then finally, internal walls are made out of aluminium cans in a cement mortar. So that's adding thermal mass inside, where that also helps to reduce fluctuations in the temperature. And one last thing, the shallow floor plan, you'll notice the Earthship is only really one room deep. That makes sure that, you know, solar energy can get into each room. There's good natural daylighting, you know, rather than a typical floor plan, which is, you know, usually 2 or 3 rooms deep with corridors and whatnot. In this design, the corridor is really the greenhouse. That's what helps you get to all the other rooms. This is a slightly different design Earthship called the Simple Survival Model that Mike Reynolds developed for Haiti. They had a big earthquake there, and he was looking at solutions for them. And this is what my Earthship is based on, this design. I've changed a few things, but some of the basic construction systems are the same. For example, the tyre walls obviously, but this is called a bird cage ferro cement vault. So you actually form up rebar, steel rebar, put some chicken wire on it, and then you splatter a thin coat of cement on it. That makes a very strong shape, which you can then load earth on top of. And I've put gravel on top of mine. Mike puts more concrete on top, but I put some gravel on. I think it's going to be great in bushfires. I'm still going to be able to collect water. So that's a really interesting design because you can very simply replicate it. You can easily teach people how to do one of these, and then they can replicate it. You know, when you've gone home, they can keep going. Because one of the great things about Earthships is the techniques are very easy. You know, you just spend half an hour with someone and they're an expert on pounding tyres. And so yeah, here's a simple survival model ×5. I'm sort of putting it out there that, you know, we Australians, because we build the biggest homes in the world, we really need to do something like this if we want really big homes, because, you know, that's going to reduce the impact. This is what the CSIRO are proposing. This is their, you know, ultra energy efficient home, and you know, it's got a lot of great ideas. Here are some of the features. You know, blah blah blah. I'm not going to read them out, but the things that I've kind of highlighted is it's still got a 6 kilowatt solar panel system on it. That's massive. That's to power the you know, the reverse cycle aircon. That's kooky, right? So here's a bit of a comparison between the Earthship and the Aussie by CSIRO. And you know, it's not doing water harvesting, it's not doing natural and recycled materials, and they're not thinking about how you're going to grow food. And yeah, you know, renewable energy, 6 kilowatts seems a little excessive. In contrast, the Earthship, it makes it really easy to be green. That's kind of the game we're trying to play here, is how do you present something to people that they're gonna not, you know, react violently to and go, oh, you know, I haven't got all my mod cons. They still want to be able to do everything that they usually do, you know, watch TV, do a load of washing, and, you know, you can do that in the Earthship and do it in a way that, you know, you're not needing all these kind of nasty coal-fired power stations and, you know, chlorine treatment plants for water. So this is some of the research I did. I went to Taos, I talked to people who lived in Earthships, and this is the kind of thing they're saying. They love living in Earthships. They really do. It's not cramping their style at all. This is the way they want to live, and they're not weirdo hippies or anything. You probably think I'm a weirdo hippie. I'm not. I've just got long hair. I'm fairly normal. I'm a university lecturer. You know, I'm not convincing you, am I? And I'm going the wrong way now. So water harvesting, this is how the Earthships work. There's all these underground tanks back there. You can see that the roof system is really simple. Just, you know, it just drains back into a gutter, nice and close to those water tanks. They do a little bit of water filtration. I think in America they're pretty paranoid about, you know, some of the stuff they've got in their air and, you know, stuff that might be falling on their roofs. I live in a house where we just drink rainwater, unfiltered rainwater, and I'm okay. But so all these filters probably aren't, you know, really necessary in my opinion. I'm not going to bother with this stuff. I'm just going to have a little filter under the sink in the kitchen and in the bathroom, just to do the filtering right there at that end point. This is the water recycling. And the idea is that you're using water 4 times. So first for a bath, shower, and the laundry, then you're irrigating this indoor garden, and the roots of the plants are just, gobbling up that water, dealing with bacteria, and then ultimately you can use the water at the end for toilet flushing. And Mike did lots and lots of experiments with composting toilets and solar composting toilets and stuff. But he just found in the end that people hated them. They couldn't deal with it. I've got a composting toilet in my house and I love it. But Mike says they're like having a pet. You just have to look after them. You constantly got to be getting sawdust and tipping it in and changing the barrels and doing composting. And it is like having a pet. I think it's a good analogy. And then 4, you're irrigating the outdoor garden. So using it 4 times, whereas in our homes, we use it once, right? We just use it once pretty much. So these guys, they're self-sufficient in water and they only get 250 mil of annual rainfall. That's half of what Adelaide gets. So we're just being wasteful. Oh, the ones in red there are the ones that I wasn't allowed to do when I tried to get approval. They said no dice, no matter how nicely I asked. So there's one of my favourite shots. I took this photo of a greenhouse in an Earthship in Taos, New Mexico. You can see snow on the ground outside. One of the great things about Taos is there's just so much sun in the winter. And so this is another thing I'm concerned about in our climate. We don't get all that sun in the winter, but it's the most beautiful place. That's a banana, like they grow bananas in there and all sorts of tropical fruits, and it's just like magic. And it could be 0 outside, 30 degrees in there, and then 20 degrees inside. So it's truly like magic. It just blows your mind. So yeah, grey water treatment, gardening, food production. It's a corridor, captures heat for the winter, and that natural convection for pulling through the air through the earth tubes in the summer. It's a thermal buffer zone that kind of tricks the house into thinking that it's warmer outside than it really is. It produces oxygen, removes CO2, and it's beautiful. So why wouldn't you want one? There's the outdoor blackwater garden. And as I've said already, living off the grid really forces you to live within the limits of the system. You don't want to run your batteries out, and you don't want to run out of water. So you're instantly going to change your behaviour to make sure those things don't happen. So this is, I think, one of the really interesting things about living off the grid. I've kind of been through that already, but just to reinforce, there is no heating or cooling in these homes. It's just all passive, and it's just amazing. Like sometimes it was minus 20 outside at night time, and it would still be 18 degrees inside. That's a massive difference in temperature. There's the berm out the back there. That's what's doing the work. That is actually what's enabling this to happen to a large degree, because that berm, all those hundreds of tons of dirt, is stabilising. Again, it's tricking the house. It's saying, no, it's not minus 20 outside. It's 16 outside, because that's the temperature of the earth. There's skylights and vents to help with all, cross ventilation and getting light into the building. There's an earth tube under construction, and there's an earth tube hatch inside the home, and sort of a few other designs. How am I going for time, Ken? Good, about halfway through. That's the earth tube on the outside, all airtight and sealed up in the winter, so you don't get sort of cold air filtering through in the winter. Now, waste. As I've said, you don't waste water and electricity in the Earthship, because you're going to run out, and no one likes running out of those things. But here we've got a big pile of waste, and Aussies are great at making waste tyres. This isn't a pile in Australia. What we do with our tyres is we put them all into shipping containers and send them off to China, where they get burnt in waste to energy facilities or in cement kilns. Apparently, yeah, works pretty well if you chuck a tyre in a cement kiln. There's lots of energy in a tyre. I'm actually not criticising it. It's probably not a bad idea. But the particulates that might get released into the atmosphere is not great. So Basically, Michael Reynolds is just responding to this problem and saying, well, here's a material that we're just not using to its full potential. And it turns out they are a great building material. And Mike likes to tell a joke, which is that, if you gave him $1 million to design, the ultimate building product, he'd design a tyre. Because why are they so great? They're so durable. They're one of the most durable things we've ever designed. You think about it, they can survive thousands of kilometres of abrasion on asphalt. They can survive, hot temperatures, cold temperatures, acids, petrol, this, that and the other. And you're building a wall that's slightly, sort of rubbery, resilient in an earthquake. It's going to just kind of give a little bit. I'm speculating a little bit, but they're actually starting to do tests on and stuff. I think there's a guy planning a shake table test with an Earthship, and there's a few earthquakes that have happened where Earthships have been located. So and those walls have stood up. So this is a company in New South Wales, EcoFlex, that also build with tyres. They've been doing that for decades. They use truck tyres and they just pour gravel into them. They don't pound dirt, they just pour gravel in. Pounding dirt takes too long, too hard. So they just tip gravel in, and they're doing projects all over New South Wales. And the great thing about that was I actually used a lot of their research data to help me convince, building certifiers and whatnot that this was a good way to build, a home. Now this is, as I started my talk, I said, one of the kind of things I wasn't quite sure about with Earthships and I wanted to try and, investigate was, all this use of concrete or cement. So this is a cement mortar with the aluminium cans in it. And also in a country like Australia and a state like South Australia where we've got a deposit on these things and we've got really good recycling facilities, it was kind of in my mind, I wasn't quite sure if this was a good idea. Maybe there's better things to do with our waste aluminium. So that's one of the things I looked at in my study. But what we've done at Earthship Ironbank is we've been experimenting with just using mud, and these are bottles rather than cans, but similar kind of idea. We've actually kind of been bad here and used cement-based mortar, but that was for other reasons. So moving on to my research, I've sort of got three main things. I've got this post-occupancy evaluation, which just means going in and looking at how the building's going after you've built it. And that doesn't happen enough. All too often we just go, design a building and the energy assessor goes, this is going to be a 9-star home. And guess what? No one ever goes back and measures and finds out whether it's a 9-star home. It's maybe it's not as good as they thought it would be. So I went and talked to people. I asked them, I got them to fill out surveys and, what was how did you feel at this particular time? Was it hot, cold? Did you want it to be hotter or colder? And I actually compared that to what I measured. So I was measuring the temperature inside 6 Earthships inside the living space in the greenhouse, so I could start getting an understanding of, how they're actually performing. Then I did some simulations in the Adelaide climate, so we could start to, understand how they might perform in our Adelaide climate. And finally, I did life cycle assessment, which looks at the cradle to grave environmental impacts of, constructing it, living in it, and then eventually demolishing it and recycling it. So here's some of the temperature monitoring. These are some of the temperature sensors I put into it, and also outside, because it's important, obviously, to see what's going on outside. That sort of produced data that looked like this. So you can see here, this is a winter week inside the Earthship in Taos. And the measured outside temperature is the blue one, so you can see down here -15. The measured inside temperature in red, so you can see it's just kind of hovering in the comfort zone. And then the simulated inside temperature is what my computer model was saying would be happening in the Earthship. So although my computer model wasn't perfectly accurate, it wasn't bad at sort of predicting what would be happening inside that Earthship. This is a spring week. This is the summer week. Again, you can see it's all sort of fitting inside that nice temperature band that most people find comfortable. And so I was asking the question, how would it perform in Adelaide? So I then took my model that I'd sort of calibrated in Taos using that measured data, and I simulated this. This is what the computer said would happen to an Earthship in Adelaide using the Kent Town climate data. And then in a summer heat wave, the Earthship hopefully wouldn't get up much above about 26 degrees. And I also simulated in Mount Lofty because I sort of live halfway between Adelaide and Mount Lofty, and that's kind of indicating that sometimes the Earthship might need a little bit of backup heating, maybe a little wood fire or something like that would help boost it. Then what I did was I did energy modelling on various types of walls, straw bale, rammed earth, mud brick, and conventional stuff like brick veneer, reverse brick veneer. So I just had a standard roof, R5 insulation. Sorry, I should say that was just what I applied to all the models. All I was really changing in the models was the wall material around here. So in one I'd try tyres, then I'd try straw bale, rammed earth, brick veneer. That was all I was changing. The other thing I was looking at was what happens when you put a greenhouse on. So I was looking at the effect of having or not having that greenhouse. And this is what I found. So at the top we've got all the star bands, a 10-star home down to a 6-star home. That's the minimum these days. And so the Earthship came out on top, the insulated and bermed Earthship, the way Mike Reynolds does it. I also looked at not berming the Earthship because in suburbia you don't have room for a berm. You don't have room for tons and tons of earth around your Earthship. So I was interested to see how that would perform. Performs really similarly to a straw bale home. Then here, rammed earth insulated, and compare that down to just your standard rammed earth. One of the problems with rammed earth is they don't actually insulate too well. Whereas if you put a layer of insulation on the outside of them, insulation on the outside, thermal mass on the inside, it does tons better. Okay, and then here the green versus the pink is when you add the greenhouse. So you can see in all cases, when you add the greenhouse, you're getting benefits. Okay, that assumes though you've got that if we just go back to the previous one, this is like north facing and you can just add that greenhouse. So the greenhouse, I think, if my computer modelling is right, the greenhouse is of great benefit to all types of wall constructions. So then I took what I found from that and applied it to the life cycle assessment, trying to quantify these environmental impacts. And the way I did that was, using that energy required to heat and cool the home over its 50-year lifespan. And that's the biggie, right? Because, that energy, you got to multiply it by 50 years. That's ongoing. But to work out the embodied energy of the materials or the environmental impacts of the construction materials, I looked at sort of a module of wall. So here you see an Earthship tyre wall, just sort of one tyre wide, stacked up all the way to the bond beam on top. And I even included a footing in some cases. I wanted to see what would happen because some engineers are mad keen on having a concrete footing down there, whereas you don't really need it. But I looked at both cases. And you sort of plug all those materials into, then I sort of multiplied it by the length of wall I had. So I had all the materials for the home or for the wall in the home. And then it gives you this network diagram, it's called, which shows me like the thicker the arrow, the more impacts. So we can see here that the bond beam, which is this bit up here made out of concrete, that is leading to a lot of the impacts. And also the foam in the berm, the polystyrene foam is creating a lot of the impacts. So that was sort of an interesting thing to find out. And this is one of the reasons why I haven't used any polystyrene foam in my berm, because I wanted to sort of reduce that. And so then this is the global warming potential of a whole lot of different types of homes. So we've got brick veneer, concrete block, Earthship insulated, that's without the berm. Here you can see the orange is the berm, that's when you add the berm. You can see this is increasing the environmental impacts by adding that berm. to the construction stage. But remember also that the berm is also reducing the amount of energy that you use over the 50-year lifespan. So, you know, this is the sort of balancing game you're playing. Straw bale, rammed earth insulated, rammed earth, reverse brick veneer, mud brick. This is the Earthship with the footing. So you can see the footing is this purple bit. You know, that's a significant contributor to the global warming impact. Now, at this point, I'm just gonna skim through a whole lot of graphs because I don't want to put you to sleep, but I wanted to give you a sense of the process I went through. So I did this that was global warming potential. This is ozone depletion, photochemical oxidation or smog, eutrophication, which is nitrogen and phosphorus that pollutes our waterways, land use and transformation, basically cutting down our forests or, you know, what have you, water use and depletion, solid waste, embodied energy, and human toxicity, carcinogenic and non-carcinogenic, and ecotoxicity. And I'll just talk briefly about this one because the Earthships are getting a really bad deal here in the berm. That was because one of the materials I selected which was a jute, like a geofabric, which filters. It's a filter system. There's sort of a drain around the back of the tyre wall to take water away, and the jute. Turns out that all the software said the jute had all these pesticides were involved in its manufacture. So that's why it scored really badly on the ecotoxicity. So, you know, there was stuff like that I had to question sometimes and interpret. And so the last stage of the life cycle assessment was, is where you actually weight all these results, where you say, well, global warming is the big baddie, and all these other things are slightly less important. And that's really controversial because no one agrees on that. You can ask different people and they'll give you a different idea of what's more or less important. But I used the Building Products Innovation Council's recommendations and just ran with that. And that gives you this Eco Points score, which it's not an absolute thing. It just sort of shows you that this one is about 3 times as bad as this one. So at the end here, we have the Earthship insulated, which is the one without the berm. Then you've got mud brick, the Earthship with the berm and the insulation. And this one actually had, I assumed in this one that the aluminium cans would be recycled at the end of their life. Whereas this one, I assumed the aluminium cans would be landfilled at the end of their life. And there were a few other differences there, like this one had slightly less concrete than this one and stuff like that. Here's the straw bale, very similar to this Earthship. Timber frame, rammed earth insulated, brick veneer, reverse brick veneer, the Earthship with the footing and landfill of the aluminium cans and the concrete block. And you know, you can also see, like, if you discount the solid waste, which is this bit up here, you know, you'd actually get a different ranking of these. So, you know, it's not a great system, I want to say, but it's actually the best system we've got at this point. It's one of the most sort of rigorous scientific methods for evaluating this. So that was the wall. So this is the whole thermal envelope with, like, the roof, the greenhouse, the floor, the internal walls, the glazed wall, that one that separates the greenhouse away, and the external wall is the green bit at the bottom. So I kind of repeated this procedure again and again for the thermal envelope. That's the weighting of the thermal envelope. The mud brick comes out really well in that analysis. And then I did it for the off-grid versus the grid energy system. So here we've got off-grid, here we've got the grid. And I did it for the water supply. Again, you can see a huge difference there. And this is because you just use a massive amount of electricity to pump water around. It's the biggest energy user in the state, apparently, just pumping water from point A to point B. That came as a big surprise to me. And the wastewater system. Also, you know, that's indicating that, you know, it's reducing the impacts by more than half. And then so you put all that together. So, you know, the wastewater system, the energy system, the water catchment system, the thermal envelope. The thermal envelope just means the roof, the floor, the walls. And this is what you get. And the thing you find is that these ones here, this is the Earthship. This is actually the mud brick with off-grid systems. I thought, let's just, you know, let's do that for the mud brick one. And, you know, the point is, you go off-grid with any one of these things, and you're going to dramatically reduce your water use and depletion. In particular, as I said, you know, that's where you know, the water use is actually using a hell of a lot of energy and leads to a lot of environmental impacts. So that was kind of the interesting finding that I wasn't really expecting to find, was that going off-grid could have such an amazing impact or reduction of impacts. So these are my conclusions. You need to minimise heating and cooling. I mean, a lot of this is really obvious. Minimise energy and water use. Low impact materials are important, but not as important as those other things. So if you use a bit more insulation, that's a good idea. And you know, so how do you achieve all of this? Well, Earthship construction and design makes all this very achievable. But if you don't have an Earthship, a greenhouse retrofit is a good way of improving energy efficiency. And yeah, look, the overall aim is to minimise reliance on the grid. Get rid of it. Don't need it. So, sort of in conclusion, to wrap up this presentation, I want to just show you a little bit about my project in Ironbank. It's a bed and breakfast, so everyone can come and experience it. That was one of my main goals. I really, you know, wanted people to be able to come and check it out. It got approved about a year ago, all except for the wastewater approval. Yeah, and it was really a matter, how did I get it approved? Because when I started off, I thought, oh, there's no way I'll ever get this approved. And I started building without approval. And actually at one point, I got told after I got planning approval, because council came out and had a sniff around and said, hello, you're not meant to start building until you've got building approval. And they asked me to stop, and I said, that's fine, I'll stop. And I started building a little chook ship, which is under the 15 square metre rule. You can actually build if it's under 15 square metres and lower than 2.5 metres high, and et cetera, et cetera. All you have to do is think you can do it, and you can do it. You just have to find the right people. The first engineer I spoke to was like, nah, no dice, you haven't got concrete footings under there, not interested. Second engineer I talked to was like, that's fine. Complies with the National Construction Code. National Construction Code doesn't say thou shalt not build with tyres. Just says you got to build a wall that will stand up and perform under, you know, bushfire, blah, blah, blah conditions. So you got to find the right people. The other thing you want to do is with planning approval. On my plans I put, instead of writing tyre wall, I wrote rendered stabilised rammed earth wall. But of course for the structural engineering, I told the engineer we were using tyres, and he gave it the thumbs up, and then the private certifier, he's happy if, or she's happy. If you know, the engineer's happy, then the private certifier's happy, because all it is this passing of the buck of, like, you know, if the wall falls over, who's going to get sued? So that's the way it seems to work, and you just got to find people who are happy to take on that risk. I guess it is a bit of a risk, because it is, this is actually the first approved Earthship in Australia as far as I know, and it's also the first one that Michael Reynolds from Earthship Biotecture sanctioned, gave the thumbs up to. So yeah, thank you. So cheers. So that's it there. You can, there's a Facebook site called Earthship Ironbank, and you can certainly come up, and there's a open day organised as part of this on the 3rd of May, Saturday afternoon coming up. This is Mike Reynolds, the guy with the white hair and the level, pounding out the first tyres, and about 25 architecture students from UniSA came up that day and helped out, and that's Brett Aylen of TS4 Architecture. It's fun, easy, low-tech, social. Kids love it. Have a good time. There's some more campers. There's a facing crowd there. I can see in the second back row. That's my son Zephyr on the right. That's doing the hard yards there with the sledgehammer, pounding dirt. I can only do about 10 tyres a day, then I'm totally stuffed. So, I mean, this is, I guess, one of the limitations of the Earthship is that you do rely on a lot of volunteer labour and goodwill. I mean, there are mechanised ways of doing it. As I said, you know, I gave you that example of EcoFlex that just tip gravel into the tyres. But look, you know, what you're trying to do is make a retaining wall so you can berm it, and that leads to a lot of energy savings and thermal efficiencies. And so there's just a few photos of it here showing it going up, and one of the mistakes I made, and I probably should have haggled a little bit more with the engineer, is that there are some fairly sizable chunks of concrete in through here. That's 150 thick. That's a big bond beam on front of the tyres that the greenhouse kind of sits on. And I've talked to him since about it, and he's like, yeah, you know, we can, next time we do this, we can you know, address all of that. That's sort of a view from the back corner. Here, this is the ferro cement, the rebar, the chicken netting on it. There's a main vault in the middle there with dirt on it and gravel. The CFS guy who came and looked at it was like loving it. He was like, this is going to work great in a bushfire. There they are putting the cement layer on the rebar. You can see it's all propped on the inside with timbers. And here, this has actually got a layer of hempcrete on it. Sort of experimenting with different materials, the hempcrete is an insulative layer. This is our drag afternoon. This is testing out the load-bearing capacity of the roof. There's a lot of people and also a lot of dirt and gravel on top of the roof. It's probably holding about 20 tonnes there. And this is the mud bath. This is actually a big water tank that will be used for firefighting purposes, although at the moment I'm planning to convert it into a swimming pool. You forgot the water, yeah, that's coming. Just to finish this off, I want to, because a lot of criticism about Earthships is that it's not going to work in the suburbs. Well, here's a suburb that's been designed from scratch in the Netherlands. I've actually started constructing this. This is one of Mike Reynolds' pipe dreams, you know, cities, Earthship style, sort of built up in, you know, pyramid type formation. And this is some of his practical experiments in, you know, quite high density, split level, you know, Earthships side by side in, you know, not high density, but medium density. And this was one that was planned for Brighton, England. This is a design, really nice design by TS4 Architecture. Brett Aylen and Paul Hendy did this for a block down at the Aldinga Arts Eco Village. Like really tight little block, but they managed to kind of fit it in there. Did a brilliant job. And you all would have seen this, I reckon, on Grand Designs. This is in here to show you that an Earthship doesn't have to look like something that's landed from outer space. It can look quite normal. Well, not normal, but different to the way Mike Reynolds does it. So in conclusion, our homes of the future may not be called Earthships or look like Earthships, but they'll need to be doing everything that Earthships do, and we need 2 billion of them right now. And so some of the things that we're doing is we're doing backyard shelters. Like there's been all sorts of little mini ship projects happening around Australia, you know, that coming in under that 15 square metre rule. But yeah, you know, look, I think there's going to be lots of new Earthship homes, even Earthship suburbs, or even just taking those Earthship principles like the greenhouse and tacking them onto existing homes. And this is my last slide. This is a quote from Michael Reynolds. This concept of living could change the nature of the human mind itself. It could provide a basis and a direction for conscious evolution on Earth. And I feel that that's probably pretty true. If you have a living room like that, you can reach up and grab a banana while you change channels. Yeah, that's it. Cheers, bro. Let's have a glass of water.
Many thanks to Marty for his presentation.